Hello, everyone. Welcome to Hackschool Week 9.
Um,
My, yes, are you going to say something? I guess not.
wait, the music. Oh, just kidding.
Okay.
I was playing it myself for my own ears, and I forgot. It's fine. Continue.
Yes, okay. Yeah, so again, welcome. My name is Timothy Gu, and Jamie and I will be talking about Node.js and server technologies today. So we have a welcoming poll for people, which I'm going to end right now. Let's see. So it's week 9. How are you feeling? Looks like our most popular answer is looking forward to break. I am certainly myself looking forward to break. And looks like people tend to have, there's some tendency that people seem to be stressed right now. And I certainly know that I am with 4 papers and like 4 or 5 presentations ahead of me for next
All
two
right, you can
weeks.
stop flexing.
Okay, I'm not flexing. um,
Um,
Whatever.
yeah,
Yeah, you wanna cover the
sure.
Thanksgiving break?
Looks like Thanksgiving break was too short for everyone. I definitely feel that as well. But luckily, winter break is almost here, so just gotta make it through the next 2.5 weeks. We can all do it. I believe in all of us. Yeah. Okay. So with that, let's get started with the workshop.
Yeah, so here's as usual, here's the link to our slides. If someone can send it in the chat, that'd be great. And also for the README. Thank you, Eugene. And for the README too.
I just sent all the links, so don't worry about it anymore.
Great. Okay. So today's membership portal attendance code is express yourself. The joke being that we'll be using a package called Express today to write our server. And you don't need to worry about the feedback form right now, but we just have the link here. Yes. You're welcome, Christy. Great. So the roadmap for today is we'll first take a little refresher for what exactly is a server. We talked a little bit about the client servering architecture that the web uses during week 2, but that is an eon ago. So we're going to talk a little bit about what that means again. And then we'll dive straight into HTTP, the 2 parts of HTTP being requests and responses. Then we're going to talk about Node.js and the Express package in particular. And finally, we will have a demo for people so you can actually see us running a server live. Yep. And if you're confused at any point, please ask questions. You can just either unmute yourself or just ask in the chat. We have mentors available who are all able to help. And these are just two sample questions you can ask. I don't understand the last section. Could you review the slide about blah blah, or what does blah blah mean? Yep. Okay, Jamie, you want to get started?
Yeah, so first we're going to go into a bit of like background information. So say we made some sort of web page and we want to show our friends. Maybe it's like a Bobo review site or it's an instant scam app. But in any case, we made this really cool web page. We want to show our friends. But we're being responsible and socially distancing and everything. So we can't just like pull it up on our laptop and show them in person. So we want to use another method, right? So one possibility, can you go back a slide?
Sorry.
One possibility is like, we could email them all the code or send it through Google Drive or GitHub or something. But this is kind of inconvenient because then, our friend has to like download all the code. Like every friend we want to show has to like download all the code and try and like run it on their own computer. So that's kind of like a hassle. So how can we work around this issue? Now, next slide, please. We can put our web page on a computer that's always running, and we call this computer the server. So in the little diagram, it's the one on the right. And this computer can serve, that's where the word server comes from, I guess, our page whenever the client computer requests it. So that way, like, we can just send our friends some sort of URL or link, and then their computer can request the site from that server without having to download the code and run it themselves. So you might remember if you, yeah, you might remember from Hackschool session 1, which was like eons ago, but we learned that like if you type a URL in your browser and you press enter, your computer is actually going to make a request to some like server to get all the files for the web page. So that could be like HTML, CSS, JavaScript. Yeah, so go ahead. And also just for some context, like when we say server, we really just mean the computer. So you might think of like, like this sort of huge server center thing on the left that like, I don't know, maybe it's from Amazon or Facebook. I don't know which one it's from. But each of these things are really just like computers. Like it's just a whole collection of computers. So when you're like making a request to Facebook or Google or whatever, you're really talking to like one of these computers. And just for fun, like a normal computer can also just be a server. So on the right here, we have my desktop computer, which is not here, but in LA. So that's kind of sad, but let's move on and look at a real life example. So next slide, please. Okay, so say I'm Timothy Gu and I'm just browsing Facebook and I go to my favorite group, which is UCLA memes for sick af tweens. And, I want to feel some solidarity because finals are coming up and I'm really stressed. So when we actually go to this page, our computer, like I mentioned before, is going to make a request to some sort of Facebook server. And we're going to get like, all the information about the page, like the memes and the about the page and everything. And then our browser is going to display it for us. So now we can look at memes, right? And say like, we also are procrastinating instead of studying. So we like made a really hot meme and we want to share it with everyone at UCLA because we're super funny, right? So we can actually upload this meme to Facebook. Can you go to the next slide? By creating like a post and, uploading the picture to the group. And if we do this, what we're actually going to do is send our meme to the Facebook server where they're going to like basically say, okay, here's a new meme. So now if someone else requests the group page, they're actually going to be able to see the meme that we uploaded, which is great. So we know that back, can you back? So yeah, so our client, which is our computer, can communicate with the server in multiple ways. So we can get memes from the server or just any page in general, but we also can send memes or posts in general to the server. Okay, next slide. All right, so we live in like a very digital world, right? We have like millions or maybe more computers like all over the earth trying to communicate back and forth all the time, right? And they need to have some sort of common mode of communication. Like if we think about it, like how do computers actually talk to each other? Do they talk to each other in English, in Chinese, in Spanish, or like something weird like Morse code? Like how do they make sure that they can structure the messages so like the other computer can understand? So if we think about all these questions, we realize that we need some sort of standardized way of communicating. And that is an introduction to why we have this thing called HTTP. So now Tim will take over and talk about that.
Yeah, so so HTTP, you probably have seen this before in URLs and maybe in other in other places. But what HTTP really stands for is Hypertext Transfer Protocol. So we have a few keywords here. One of them is being protocol, which is just in computer science means a way for an agreed upon way for different computers to talk to each other. We also see this word hypertext. You may remember this from HTML, which is hypertext markup language. So HTTP can transfer more than just HTML files, but the origin of HTTP was around the same time as when HTML was created. So that's why it has that in the name. So as we mentioned before, HTTP defines how clients and servers communicate. And we have this two-way conversation going on where the client will first send an HTTP request to the server. And afterwards, the server can respond to that request with a response message. And in fact, like these are not just like abstract things that we can't see, but we can actually like take a look at the messages themselves in order to better understand how HTTP works. And that's exactly what we'll be doing soon. So, so the first thing we got to do as a server is understand what the request is for, right? So, so when we went over two major scenarios, we can either get memes from the server, or we can like upload new memes to the server. And the server has to have some way of identifying what's the case for that particular request. And that contributes to something we'll see in HTTP requests. So a request in general contains two parts. There's a header and there's a body. So and the header again has three additional parts. So we have the HTTP method, which defines the type of request, get versus post, and even other possibilities. We also have the endpoint, which is essentially the URL that the client is requesting. We sometimes the client will also send additional information to the server in the form of HTTP headers, and we'll see examples for all of these later. And aside from the header, we also sometimes have the body, which contains information you want sent to the server. So, for instance, if you're uploading a meme, then the body would generally contain the meme that we are sending. So again, we talked about the two types of requests. There's get and post. So so this is actually what tells. Or actually, before we get there, we have to first talk about URLs. So URLs are these like ubiquitous strings that you see everywhere these days. But it's not like meaningless. The computers actually read this and try to understand what exactly it means in order to send you to the right web page. So here we see three parts: the HTTPS, the www.facebook.com, and the /group/zoom/. So the three parts are all meaningful. So HTTPS just means secured HTTP, which is a protocol. And then we have the host, which is a facebook.com. And the host essentially just identifies which server you're trying to talk to. So if I want to visit Facebook, then the browser would send the HTTP request to the Facebook server. We also have the path, which identifies which resource on that server that we want to access. So in this case, we want to access the Zoom memes group in particular on Facebook. So so this is what the path is. Sometimes you can even see things even after the path, like with a question mark or with a hash symbol. So so those are meaningful as well. I'm not going to spend the time to talk about it here, but it is on the README if you're interested to learn more. So once we talked about the URLs, we're now able to jump into a discussion of different HTTP methods. So I mentioned before that we have two main things we can do with HTTP. The first one being like getting memes. And that's exactly what GET requests are for, the GET request method rather. And on the right, we actually have the actual HTTP request message shown here. And this message is actually what your computer sends to the server. And the server will dissect it and try to understand what the request is for. And then out comes this particular web page that you see here. So if we take a look at this, we see that the first line has get. It also has the path of the URL. And then we see two more things: the host and the accept, which we'll call the headers. The host header just contains the host part of the URL, while we also have a separate header called accept that we're not going to go too much into right now. But yeah, so this is like actually what your browser sends to the server, which is like pretty cool to know. We also have a second form of request called, or in fact, before I go there, let's do I'm just going to pull up DevTools so that we can see if how this is actually happening. Let me go back real quick. So let's just go to a Hack website, and I'm going to open up DevTools. So so in Chrome at least, DevTools has this tab called Network. I'm just going to clear everything and refresh. And we should now see the very first request is towards hack.ucla.acm.com. And if we go to the headers part, and I'm going to close the response headers right now, but you see that pretty much everything we just talked about actually exists in the DevTools. So we talked about the request method. Oh, I'm sorry. Is the font size not big enough? Hopefully this is better. So yeah, so we actually see all of those pieces of information that we just talked about. We talked about the request method. It's called get. We also have the path. So here it's represented slightly differently, but the path here is just the endpoint, so just slash. We also have an accept header like we talked about. And we may not see the host header specifically because it's known as authority in this layout. But we also see a bunch of other random headers that we see here. And they all have their own meaning, but we don't have to worry about them that much right now. So yeah, so that's sort of what a get request looks like. It's got a method, it's got a path, and pretty much nothing else. Okay, let's go back and we'll talk a little bit about the next type of request, which is the post request. So as we mentioned before, when we want to post something, or when we want to create a post, we'll do a post request. So let's just say in this case, I want to send a meme to the UCLA memes group. In that case, what Facebook could do is create this post request. We see that over here, we see that a lot of the parts from the previous get method is still here. We have the method, we have a URL looking like thing on the first line. We still have the host and accept headers, but now we also have two additional headers. We have content type applications.json, and we have content length. But more importantly, we have this body right here, which is basically the meme I'm trying to send to the Facebook server. So in this case, we're doing something a lot more simplified, where I just say meme : picture. But you can imagine, Facebook's going to encode the picture in some way to fit into this format, and that can work. But in this case, in this scenario, where our body has a format JSON, which is something we went over earlier this quarter as well. So because of that, we have to set content type header to be application.json, so that the server can understand what format the body takes. We also see a separate thing called content length :19. And that is essentially a number of bytes or a number of characters in the body. So if you were to count 1, 2, 3, 4, 5, 6, if you were to count all of the characters, you should see that it's exactly 19. Either that or I can't count. So this is how a post request looks like. And I'm not going to do a demo right now because Facebook actually does something a lot more complicated than this, because they want to hide their new features from prying eyes, so they tend to do some encryption like things for these. So I'm not going to be able to demo that, but yeah. Do people have any questions at this point about anything related to HTTP or HTTP requests? Request methods. Rohan asked, wait, why was content length 19? So if you look at this body, and if we try to count how many characters is in this body, so the left brace is 1, double quote is 2, M is 3. If we try to count up all of these characters, we should eventually end up with 19 as a content length. If I log in, then this is a post request. I'm not going to answer that because it is a poll question, unfortunately. I think.
Wait, it's definitely not part of the poll because it was too nuanced, I feel like.
Okay, it's too advanced for the it's too nuanced for the poll. So I'm just gonna go over real quick. So for login, you can actually do either way, but most websites use post, because you can think of the username and the password as like things to send to the server, and those will belong in the body. So in that case, it would be a post request. Josh, what's 1.1 in HTTP /1.1? So that is a version of HTTP that we're using. So HTTP has a few versions that are in common usage right now. There's 1.0, 1.1, as well as HTTP/2, and they're in the process of making HTTP/3 right now. So 1.1 is this version, and we see that this particular format is the 1.1 format. In HTTP2, it doesn't look like this anymore, but it's very similar. But we just picked 1.1 for readability. Any other questions? Rohan said, if we have a user post request, do we encrypt it before sending it to the server? So that depends on whether or not you're using HTTPS. So if you are, so like refer back to the slide when we were talking about URLs. So in Facebook's case, we are using this thing called HTTPS with the S, standing for secure. So if you're doing HTTPS and you're posting to a website using HTTPS, then yes, you are having it encrypted. What people used to do back when HTTPS wasn't common was that they would do the encryption themselves before doing the post request. But people don't really do that anymore because HTTPS already does it for you in a very secure way. So it's not as common anymore. Hope that answers the question.
I'm going to launch the poll now.
Great.
Okay, so just go ahead and try and answer these questions. And if you have any questions, feel free to ask them still.
Okay, let's see it. So the first question we had was, does an HTTP request always have a body? And we see that most people said no, but there are a few people who said yes. So for this, let's go back to the GET request. The answer to the question is no. The request does not always have to have a body. And we see that with the GET request here. So here we only have the method, the endpoint, and the HTTP version, as well as some headers, but we did not attach any additional information, additional body to the request. And this is in contrast with the post request we saw as well, where in addition to the headers, we also had this additional information known as a body. Yeah, and usually when you have a body, you tend to always also have the content type header as well as the content length header. The content meaning the body content. The second question was, if I send a DM to the ACM Hack Instagram, which is at UCLA Hack, then what method will be used? So looks like everyone got this right. It is like post. It is a post method. So usually, if you want to send something to a server, including a piece of text, other things, that would be a post request. If I upload a picture to my Instagram, what kind of request method will be used? Same thing here. We're sending information to a server, and that will be a post request. Suppose we're using a web API endpoint that gets us 10 billion digits of pi. What kind of request would we make to use this API? In this case, we're just getting information from server rather than sending information. So that would be a GET request as usual. And we also have two more questions about HTML features, and this is slightly tricky. We understand, but let's look at it still. So let's just say I try to link to a style sheet file from my HTML from my HTML web page using a link element. That is, what kind of request method will be used for link? So it looks like most of you got this right. It should be the GET method. Because again, when we try to retrieve the style sheet, we're just getting it. We're not trying to send additional information to the server. So in this case, it would be GET. And the very last question was the same thing except for script. So if I say script href equals index.js, what request method will be used for that. And the answer is the same as well. It will be a get request. JB?
Okay, yeah, so we learned about what HTTP requests look like. And remember, this is the request that the client is going to send the server. So now let's also take a look at what the response is going to look like. So similarly to the requests, we have a header and a body. So in this case, the header looks a little bit different from the request. So in this header, we have this thing called a status code. And this indicates the success or the failure of the request that was made. And like the request, it can also have some HTTP headers, which will just contain additional information from the server. Now for a response, the body is also really important. So it'll contain the data from the server. So if you made a GET request from the client, then in the body of the response, usually you'll just have the data that you requested from the server. And this can be in like a whole bunch of different formats like HTML, JSON, it could be a JPEG image, plain text, and a whole bunch more. So can you click on the HTTP cats thing so we can take a look? Okay, so like I mentioned, there's these things called status codes. And here it's like kind of a cute way of looking at all of them. So there's just a funny cat picture for each of like the status codes. And we can scroll down and look at some of them. Yeah, so we can see that each one has a number as well as like a meaning. So for 204, we have no content. For 300, we have multiple choices. Okay, back to the slides, please. All right, so here's an example of what an HTTP response might look like. So you can see on the first line of the response, we have first HTTP 1.1, just saying what kind of protocol we're using. And then we also see 200 OK. So that indicates that our request was successful because we got the OK response back. Then we can look at the headers and see we have some information. In particular, we have this content type field. And we see that the content type is text HTML. So if we look at the body of the response, we indeed see that we got sent some sort of HTML page. So yeah, and we can also see the content length is 138. So I guess we just know that that's the size of the body here. Yeah, those are like kind of the more important parts of the response. Okay, next slide. Yeah, so we mentioned status codes earlier. And here are kind of like the general categories of status codes. So all of the ones in the 200s sort of indicate that our request was successful. The ones in the 400s and 500s are both for unsuccessful requests, but the 400s are for if the client messed up somehow, whereas the 500s are if the server messed up somehow. Okay. So here are some images we selected from HTTP cats. Next slide. Yeah, so some of these are pretty cute. I really like 304. It's just like a bunch of copies of a cat. It's really cute. Okay, you can also see in the middle we have 404 not found. So this is probably something that you've encountered in your lifetime because it's like a pretty common one. So this the status code basically indicates that whatever you requested, like they couldn't find it on the server, and you'll get that kind of error back. All right, next slide. Yeah, let's do a DevTools example. So if we go to ACM hack and then try and go to the URL, like just enter some random stuff and press enter. Well, that's quite a long. Okay. Yeah, so we can click on the actual request and see the response we got. So we saw that the status code is 404 because there's no such page in the hack website what that string says. And yeah, so can you close the DevTools and we can actually see the page? Yeah, we actually have like a nice not found page, courtesy of, I think, Jody, Alex, and maybe Galen. Yeah. But yeah, sometimes we'll just see like a really ugly 404, like plain text sort of looking thing. But I guess our website is advanced. Okay. Wait, can you go back to the website? Alex wants you to click the button. If you scroll down, so cute. Okay. So back to the slides. Are there any questions about status codes or HTTP responses in general? If not, we have a little poll for you guys. All right, I'm just gonna go ahead and launch it. If you have any questions, feel free to type them and we'll answer them. Also, do we want lo-fi for this? It's not going to be as long, but I guess we can play it. Okay. Wait. Oh, sorry. Okay, I got confused. We have an API endpoint. It can either give an HTML page or a JSON in the response body. And the question is, where do we find the type of the response body? Yeah, okay, so thanks for pulling up that request. So if we look at the slides here in our example, remember that we looked at the content type field in order to see what the type of our response body was. And we saw this text/HTML. So the correct answer here is in the response header. Yeah. Because if we looked at just the response body, like sometimes it might just be a whole string of like nonsensical characters, because maybe it's like an image or something. So we have to know how to interpret it, which is why we have the header. Okay, so for questions 2 through 6, we're using HTTP cat because it's cute to find the meaning of each status code. So for the first one, we have 200. Okay, I tried to pick status codes that are pretty common, so we can just go over the meaning of all of them. So this basically indicates the request was okay, nothing went wrong, pretty standard. So next, let's look at 403. And we'll see that 403 means forbidden. And this request will happen if, for example, say like I'm not an admin of a Facebook group, but I try to like edit something about the group, then I'll probably get forbidden because I don't have the like privileges to do that. For 404, we already covered that, so I'll move on, but it's not found. So 502, this is probably another sort of common one that you might have encountered, and it's bad gateway. So what this essentially means, we can tell like the server messed up somehow because it's a 500, it's in the 500s, but honestly, it's like, I think it can happen for multiple reasons, but essentially, like the server might have tried to like access another server or something and it was unable to. Maybe someone else can give a better example, but that's just, I think, one example of how you can get this error. Yeah, and then for the final one, we have 500, which is just internal server error. So this is kind of just like a generic error message. So pretty much probably anything could have gone wrong in the server. Maybe it just failed to do something properly and just returned you an error. So yeah, that's that. And I think, oh, were you gonna say something?
Oh yeah, so I put a bonus question in the chat that I just thought of, which is does the HTTP response always have to have a body? And the answer is no, because if you in fact go to 204, it says no content, which basically means we succeeded, but we don't have any body, and in that case we usually wouldn't have a response body. So yeah.
Yeah, I guess an example of where you might get that is if you try to like post something, and the server's just like, okay, yeah, it was successful, but I'm not giving you anything back. Okay, so yeah, now it's time for a bit of a break. Yeah, let's say come back in like 5 minutes. So at 6:45 Pacific time. And yeah. Okay, so you might be wondering, like, why do we just spend 40 minutes talking about HTTP and HTTP requests and responses? And we'll get to that eventually, but first we're going to talk about Node.js. So like if you Google what is Node.js, you'll see something like a JavaScript runtime environment, which is not exactly the most useful or enlightening description, but we'll sort of explain what it means and like why Node.js is useful. So in the year 30 BN or before Node, yeah, JavaScript was run exclusively in your browser, which meant that like, you know, like how these days, like we can write some C++ and just like compile it on our computer. Like if not, it's fine. Like we were not able to do this with JavaScript. So it was only available in the browser. Before some people were like, wait, JavaScript is pretty awesome. So we should like, you know, really be able to do it outside of the browser. So 2000 or actually 30 years later, we have this thing called Node. So now we can run JavaScript on our computers, even if we are not connected to the internet, even outside of the browser. So basically Node.js uses the same technology inside the browser to make JavaScript work without the browser. And this is really great for the JavaScript world because now we can run servers using JavaScript. So whereas previously we had like our front end or client or like the web page would be using JavaScript, and the backend or server would be using a real or other programming languages. Now we can actually have both the front end and the back end be running on JavaScript. And this is really great for developers specifically because now we only need a single language to code in both the front end and the back end. And also, if we want to use like tools available in JavaScript, we are like sure that they're available on both our server and our client. Whereas like if we were using a different language for the server, for example, we might have to see like, oh, does like a similar tool exist for like Python or Go or some other language? So yeah, we can basically write servers in JavaScript, and Tim will take over and talk about that a bit.
Yeah, so usually when we try to create an HTTP server with Node.js, you can do it without any additional tools or libraries or packages. But just like how last week we talked about React, and it seems like React really simplifies developing dynamic web applications. The same thing happens with Node.js. So there's a pretty popular library or tool called Express that basically makes building servers very easy. And a package is basically just a pre-built bundle of code that you can just download off of the internet, and that provides you with some pre-built functionality. And in fact, the way we can install it is by using npm, which is a JavaScript package manager, basically a manager of all of these packages that we're going to use for the server. So once we do that, we'll see in our folder we're going to see a new directory called Node modules. And that folder basically contains every package or every module that our server will use. So you're going to see something like Express in there, but not only will you see Express, but you're going to see like a lot more than just Express, because as it turns out, Express itself has dependencies or requires more tools to function. So that's why node modules can get a bit big sometimes. Inside of Express, you're also going to see this file called package.json, and that's going to basically just list out a bunch of things that Express needs to function. So for instance, with one version of Express, we see that it has like a huge number of different packages that it itself needs to function, and we're going to see all of these in our Node modules directory as well. So yeah, so with that introduction, let's actually go ahead and write the server. So again, I'm just going to show how to do it. All of the instructions are available on the README. So if you ever want to just try out locally, you can do that. But for our workshop right here, I'm just going to demo it because installing Node.js can be a bit tricky on different operating systems. So yeah, so the first thing I'm going to do is just create a new folder. So I'm just going to do that over here. I'm going to say new folder, and I'll just say Node.js server. And then I'm going to launch VS Code in this new folder I just made. And I'm going to do that right here and make it bigger because that's always useful. But yeah, so we see that we are in the Node.js server folder that I just made. And a lot of what we're going to do is going to be done in the terminal. So we briefly went over what the terminal is last week, but basically it's just a way for us to interact with different programs without using the graphical user interface or just like clicking on something. Instead, we can interact with the computer by typing text commands. And we're going to see how we can do that for this case right here. So the first thing we're going to do when we create a new Node.js project is run a command called npm init. So we cover npm which is the Node.js package manager. And we're going to say init, which is short for initialize. And that's going to create the package.json file for us. Again, the package.json file is necessary for any Node.js project, and npm init would create that for us. So yeah, so it even asks us a bunch of questions about our project in order to create the package.json file. It asks us what our package name is, which is that. I'm just going to not type anything for these because the default values will work fine for us. But yeah, so once this is done, we will see that our folder has now a new file called package.json. And once you open it, you see a bunch of standard things you see in pretty much every package.json. But now, so after we have done that, we can now run the command to install the Express package. So I'll do that here, npm install Express. So this will usually take a while. And in this case, because I did this not too long ago, it's pretty fast, but sometimes it can actually take a bit longer than that. Okay, so once we have done this, we should see the node modules folder I was talking about alongside package.json as well as package.json. And once I open it, I can pretty much see this, the things I described. I can see Express, and express.package.json has a few dependencies. Let's just look at except, for example. And if I scroll up, I should see except as another folder in node modules. So yeah, so even though I just installed Express, Express itself would ask npm to install additional packages for it to work. Okay, so once we have done all of this, we can now get started with actually writing an HTTP server using Node.js. So what I'll do is I'll first create a new file, not in this directory, not in node modules, but rather in over here. And I'm going to call it index.js. So there isn't really anything particular with the name other than the fact that it ends with .js, which symbolizes JavaScript. But index is sort of just a standard file name people use as a primary file for the server. And in our case, it's not only the primary file, it's going to be the only file we're going to be making today. So great. So we have this empty file. What do we do with it? So we know that we need to use Express somehow. And to tell Node.js that, hey, like we're going to make an app that uses Express, we have to say require Express. Like this. But that's not enough. We're going to actually save the result of this into a variable so that we can access the functions available in Express. Okay, so that's the first step. The second step is we have Express, but we actually need to do one more step to use it, which is creating an Express app. So I'm going to do that by saying const app equals Express parentheses. And if you have time to go through the documentation, it actually tells you, hey, this creates an Express application. It's a function, a top-level function exported, a bunch of other things. But yeah, so this is all you need to create an Express app. Now, so this is the time for us to talk about how to handle incoming requests from the client. And the first thing we can do is, of course, the classic hello world. And the way I do that is, for simplicity, I'll just do a GET request for this because I don't need to have a body for if I'm just getting something. So I'll say app.get, where get is the GET request. So .get equals get. And then I'm going to provide the name, which is going to be basically the endpoint that you see in the HTTP request. So in this case, I'll say hello. And so that's the first argument. The second argument is going to be a function. And the function is going to take 2 arguments. It's going to have request and response. So in the documentation here, they use some contraction, but rec just stands for request and rest stands for the response. So I'll type that right here. Request and response. Okay. So great. So now we have declared a new endpoint, which will handle any GET requests to the hello endpoint. So that's how it looks like. And now we have 2 objects. We have request and we have response. And we need to essentially, at a high level, use the information we get from the request in order to populate the response. And in our case, I'm just going to do something super simple right now, which is sending hello world text to the server, to the client. And in fact, I'm going to make it so simple that it's not even an HTML page. I'm going to say response.set header, content type, and then text/plain. Wait, what's text/plain? So text/plain is a content type value that refers to plain text, which basically means text without any formatting. Okay, so once I have done that, I can now send something to a client by using response.send. And the content is going to be just hello world for our case right here. Okay, great. Now the question is so we have the server right here, but how do we actually get it started? As it turns out, we actually need one more step before we can run the server, which is writing this line app.listen. I'm not going to go too much into how listen works, but essentially what you can do in general is put a number here. So this number we'll call the port number. And for documentation purposes, I'm going to say server now running at this thing right here. I'm going to get into it real quick. And just for information, I can say to exit type Control-C. Okay, so with this, I should now be able to run node in, so I should be able to run this file. And the way I do that is by saying node and then the file name. So I'll just that. Great. Do people have any questions at this point? So why port 3000? No reason. So there's actually a small restriction in the operating system that forbids numbers that are in the 3 digits or 2 digits or something like that. So I just picked 3000 randomly. I could have said 9000 or something or 8000. But essentially the way we access the server is going to require the port. I'll talk a little bit about this URL right here. So what exactly is this? We'll see very soon. But essentially we have started the HTTP server that's accessible at this URL. Yeah, if you're sending HTTP, if I'm sending hello world, how does it get instead of post? So so this is you have to think about it in terms of the server. So we are sending the information, but here when we say send, we're sending information to the client. With post, it's the client that's sending information to the server. So here we're actually sending data to the client. So on the other side, on the perspective of the client, we are trying to send data to the we're getting something from the server, but from the server standpoint, we're sending something to the client. Great, Jamie and Tim, thanks for answering. Okay, without further ado, I'm going to minimize this real quick and go back to the slides. So we talked a little bit about the anatomy of URL. We talked about how the facebook.com is a host, and the green part, the path, is it identifies what's on the server. So in this case, we're not we just started a server for ourselves, right? On our own computer. So we're not trying to access facebook.com anymore. We're trying to access our own computer somehow. But how do we do that? So it turns out that we can change the first part, the host, to say localhost instead. And localhost is this special keyword that translates to our own computer. And we also have this port thing that I was mentioning. And the way you do that is just by adding colon and the port number we were using. Again, I'm not going to go too much into detail about how the port works. If you're interested, then you can take 111 and 118 for that computer science courses, or you can look it up online. But essentially, we just needed to be here for it to work. So so let me go back to my code, and with this knowledge, I should be able to. Oh my god, why did I do that? So with this knowledge, I should be able to just create a new tab, localhost 3000 / hello. And there, it says hello world. Let me do this, and let me do this. Let me make this slightly smaller. And what we see here is that, in fact, when we actually access this page, we try to do a GET request on the request URL. And then what we see is that we're doing a GET request, and I think I would click the wrong one. This one, yes. So we went to localhost :3000 / hello. We did the GET request, and we ended up with a 2000 OK response, which is great because that means nothing. Everything went okay. And the information we get is hello world, which is exactly the same piece of information we're sending in the server code over here. So that shows that the server basically worked. We also see that because we use text / plain, the hello world here is without any formatting. It looks pretty typewriter-ish or code-ish, and that's an artifact of us using text / plain. Okay, let me try to catch up on the questions a little bit.
It's just the last two that haven't been answered yet.
Okay, so we could theoretically change /hello to index.html, and it will return the HTML. Yes, if we define the index.html endpoint using app.get. For deployment purposes, if I want to test out if clients could actually get my endpoint in server, what server would I put it on? Do you mean which host you put it on? And this is for Ivan. Anyway, let me try to answer it, and if I botch it, just let me know. So if you want to actually deploy this, then you will actually put this code on like a server that's always running. So not localhost anymore. There are a variety of services you can use, like for example AWS or Google Cloud Platform or one of those, where you can get a server from them and put this code on there so that you can so that everyone can access it, not just you. Because right now, when you say localhost, only you can access it. Yeah, exactly. So so to deploy it, you have to put the code on a different server. For instance, for example, we saw Jamie's computer earlier. That's still in LA. So what she did was that she plugged it into to the power outlet of one of her friends, and that computer is always running. So even though it was built for gaming, we're not using it, or she's not using it for gaming.
Can you
She
not
is.
expose me like that, please?
I'm sorry. I mean, you used that example, so I thought it was okay. But but anyway, so yeah, so in that case, that acts as a server. Um anyway, I'm sorry. Um but yes, you could use any computer for this, right? You could use a Raspberry Pi. The answer is yes, but the Raspberry Pi probably wouldn't be able to take too many requests at the same time. So cool. Yes, it is very cool. I thought the same when I was learning this. Okay, so this is pretty boring. I mean, I can try to add something here, and oh yeah, to if I want to change something here, I have to make sure to exit the server and start it up again. And to do that, you basically type Control C, and that applies even for Mac users. You can't do Command C. Um, and once you do that, you can run the same command again. And on the left, if we refresh, we now see hello world, then a bunch of gibberish I just typed. We also see though, this is not HTML. If I try to type some HTML here, like for example, strong, and I do the same dance of Control C and restart, I just see the text verbatim here. I don't actually see the HTML formatting getting applied. And for if I want to do that, then I need to essentially change the content type header here. And for that, I'm going to create a new endpoint for demonstration. So now I'm going to say app.get hello HTML. And instead of setting header to be text/plain, I'm going to say text/HTML. And text/HTML is essentially HTML formatting. The data I send is exactly the same. So the body is exactly the same. But I just change the header. And let's see how that works. So if I refresh hello, it's still the same thing. It doesn't have any additional formatting applied to it. If I try hello-HTML, I now see the Times New Roman default HTML styling being applied, as well as the bolding. So yes, great. So that's basically, and unfortunately, I seem to have copied this hello endpoint one too many times. So yes, we should have two endpoints, hello and the hello HTML. But I mean, after all, this is pretty boring. I mean, like we're just serving up HTML, but servers can do so much more than that. We talked about how Facebook can you can upload memes to Facebook through post requests. So why don't we try out some post requests? In fact, let's do that. So we can say app.post hello, or not hello, upload, and we're going to say request and response. So so we're going to do here. So yes, so what we're going to do here is allow users or clients to upload some data to my server. And in fact, what I see is that in request, there's this property called body that basically contains the body of the request that we're trying to upload to the server from the client. So it does contain that. But it appears that this body property is a bit hard to use because, like by default, Express doesn't know how to interpret the body. It's not smart enough to just look at the content type header and figure out if it's a JSON or if it's something else. So we have to tell Express explicitly that, hey, this can be JSON. So for that, we're going to put express.json here. And this is basically our way of saying, hey, if the body happens to be JSON, then let's try to decode it and put the results in body. Okay, so that's what we have here. And for the I'm going to basically get the body from the request, and then I'm going to say response.send, um, I have received some data, colon. And here I'm going to say body dot me, for example. And I'm going to do the same thing again, except now, so if I try to do a navigation from the nav bar, it's not going to do a post request, right? If I just do like localhost 3000 upload, then we're going to see that we cannot get upload because upload is declared as a post endpoint. So in order for us to show how it works, we have to do something else. We have to say, so in one of the workshops we did in the past, we talked about how to use a fetch function in browsers. So so that's exactly what we can do. We can say fetch slash upload. And then in the objects right here, I'm going to say body colon. So the body is going to be JSON because that's what the server expects to have. And the body is going to have a single key called meme or single property with key meme, and the meme is going to be a string. Sorry, I can't come up with some meme right now. But yeah, that'll be it for the body. But that's not it. So you know we understand that the body is JSON, but we have to tell the server that too. And for that, we have to use a headers property that's in the second parameter of fetch, and we can essentially say content header, content type colon application slash JSON, and that'll be it. And just for convenience, I'm going to use this feature called await, which is part of JavaScript. But I don't think we have necessarily taught in the past. But basically, all it does is to wait for the response to come back, and we can then examine the thing. Oh no, it says failed to execute fetch on window. Request with get head method cannot have body. That is my mistake. I actually forgot to put method in here. So hopefully that'll work better. Yeah, let me look at chat. In the previous workshop, we just used fetch of the URL and hit the factor. Yeah, so by default, it actually tries to make a get method, which is not going to be which is not going to work for us. We have to say method colon post. Oh no, a bunch of more errors. Refuse to connect to this because it violates the default content security policy directive. Look, I have no idea what this is. And let me try to figure it out, actually. What's going on here? So it was mentioning something related to content security policy. Looks like it's this thing. Okay, you know what? So I'm going to go back to hello endpoint, and I'm going to try the same thing from there. I can sort of explain what this is, but I don't want to do that right now because it's a bit complicated. So anyway, so I went back to localhost 3000 and then hello, and let me try to make the request again. And now it looks like the request went through, and we can look at what's in the response by saying response.text, and we're going to await it as well. So here it says I have received some data colon string. And that's exactly what we're trying to send to the server in the meme key right here. So that's what we get there. Yeah. So if I try to vary the text we're using for the meme, like an actual meme, and we do the same thing again, this time we're going to see that the server gives us I have received some data, an actual meme. Now, if I go to the network tab, I can see the two requests I just made. So I can see the two upload requests. So if I click on the second one, I'm going to see post. I'm going to see the response status code being 200 OK. And if I scroll to the very bottom, we have this request payload. And the request payload is indeed the JSON that we sent to the server. And the server is able to interpret it as usual, which is pretty neat. Okay, any questions at this point? Why use await again? So I use await just to simplify typing a little bit. So I can do this without await, but it'll just look a bit ugly. So you might have learned this type of format using this then function. And then here you can say return response.text. And then text to console.log text. So this works as well, but it just a bit tedious to type, and also await gives us like this very nice format. I can do these things in 2 different steps. Here I have to type everything at once and commit to it at the end. So yeah, await just makes it easier for me, and if you do any projects using promises, then await can make your code look simpler as well. But yeah, so that's a post request. One last thing I'm going to be talking today is so we talked about how to send JSON to the server, but we haven't actually covered how do we send JSON from the server to the client. So let me create one more endpoint. Let me call it get endpoint, and I'm going to use random as the endpoint. So as usual, it takes the second argument is a function that takes 2 arguments itself, being request and response respectively. And all that I'm going to do is sending a random number. Sending a random number in the interval 0 to 1, with 1 not included in the interval. And I'm going to say to the client. And the way I'm going to do this is by sending a JSON object. So response or Express makes that easy as well. So we can say response.json and just put in whatever object we want to send to the server. And in this case, I'm going to say number, math.random. And yep, that'll be it. So let me do the same dance. I'm going to say Control-C and then run the same command again. And over here, I'm going to basically go to localhost 3000/random. And now we see a random number being generated when we access the page. And I can refresh and see that new random numbers are being generated every single time we try to access it. And so we can tell that this is in JSON format, but how do we know if the content type header is being set correctly? So for that, we can go to network again, and I'm just going to click on one of these instances of random, scroll down to the content headers, and we should see content type being applications.json, then char.set UTF-8. So basically applications.json, which is neat because that's what we want to send in the first place. Let's see. So suppose my browser had a feature that has a feature disabling JSON from running. Will this website still function? Or is the server just going to deliver a changing HTML file? So let's see it. I can actually just disable JavaScript here. And let's see. So this is a bit hard for me to navigate. So let me make it a little bit bigger. One sec. Let's see, where is it? Disable JavaScript, there it is. Okay, so let me try to disable JavaScript, and I'm going to try to run this, try to access this website again. And we see that it still works. And the reason is because even though the data is represented as JSON, when we try to access it here, it's not using JavaScript to access the website, so it doesn't require JavaScript to work. Let's see if I can still run some JavaScript here. I wonder if I can. Okay, I can. But rest assured that if this is an HTML page and I try to put some script on there, then it's not gonna run. So the answer to your question is depends. If it's an HTML page that's trying to do a bunch of like fetch things, then no, it's not going to run without scripting enabled. But if it's the other way around, when you're just trying to access an endpoint on the server using the address bar, then it is going to be allowed, even if the user has disabled JavaScript. And let me go back here and re-enable JavaScript. Okay. Can we send a post request without JavaScript? The answer is yes, but it's a bit complicated, and it's not like the most modern way of doing things. So there's this thing called HTML form element that you can use. It is the form element. And essentially, you can specify the method of a form using this API. But again, it's pretty old, and like because everyone just has JavaScript enabled these days, people don't usually do this anymore. And it's also pretty. There are a lot of limitations. You can't do you can't run some custom JavaScript thing when the button's clicked, for example. So. Yeah, so that's what you can do in the browser. There are also command line tools you can do to send requests. And I see that Tim has mentioned curl, which is something you can do. Let me try to open up a new terminal. So if I say curl HTTP localhost, all that jazz, and hello, it's going to say hello world. Great. Curl has this thing called -v, which actually shows us all the headers and such as well. So we see that when we connect to when we send the request, it's a GET request to localhost 3000, and the one we get back has content type, text plain, content length, etc. And then if you look at the documentation for the curl command, it allows you to specify body as well, but I'm not going to do that right now. Yeah, any other questions? How do I know everything? Because I spent the time to prepare for this workshop. That's how I know everything in this workshop. In Hack, there's a long tradition of not knowing anything in the workshop until we prepare for the workshop. That is not necessarily the case for this workshop, but I can assure you that I have had that happen to myself. Anyway, that's all I had prepared for today. Obviously I'm gonna stick around a little bit more. If people have any questions related to material from this week, material from previous weeks, or anything else. And let me go open up the slides again. And of course, this is our very last workshop, so please fill out the feedback form at the end. Oh yes, there's more information you can do. There's a bunch of Express tutorials. There's the Express website containing like how do I even know the send exists, right? Like how do I know that? Well, that's from the documentation in expressjs.com. So yeah, again, thanks for coming. And I'm going to send a feedback form link here as well, so people can fill it out. But yeah,
I especially want to thank everyone for coming because it is week 9. Things are stressful, but I'm sure everyone is going to do great on your finals and whatever else you need to wrap up the quarter. And we'll all get through it.